Jigsaw puzzles are both stimulating and fun, but designing quality puzzles is hard. We present a method to create personalized, challenging, and aesthetically pleasing puzzles based on the image content and user-defined puzzle shapes. Our user interface allows anybody to be able to design high-quality puzzles. The user selects the image to be puzzled and the desired number of pieces. The user can draw a sample curve or select a saved curve that will be used to create the general shape of the puzzle pieces. Here, our algorithm can be seen automatically generating conforming puzzle piece curves. Given an input, we would like the puzzle edges to follow the prominent color lines in the image, shown in black here. Cutting along color lines makes the puzzle both aesthetically pleasing as well as challenging to solve. To create the puzzle pieces, we use superpixels to partition the image according to color regions, and we represent the pieces with a Voronoi graph. Then we solve for puzzle cuts along the edges in the graph. A term in our optimization function guides our puzzle cuts towards color lines. Another term ensures that the resulting curve is similar in shape to the user curve. It is important that the final pieces interlock with each other so that the puzzle as a whole does not fall apart. We find a minimal graph shown in green that represents interlocking pieces so that we can follow color lines where possible while maintaining a fully connected puzzle. When we trace an interlocking curve and follow its first derivative in its Gauss map, we see that the tangential angles span more than 180 degrees. For non-interlocking curves, the tangential angles do not span 180 degrees. To ensure that curves are interlocking, we impose a linear constraint during the optimization. We find the axis crossings of the first derivative of the user curve and constrain these points to their respective quadrants, ensuring that the curve will span at least 3 quadrants. We ensure that each puzzle piece has a minimum width so that it will not break easily. Puzzle pieces should also not be so tiny that they are impossible to handle. In order to output valid puzzle curves that we can actually manufacture, we need to make sure that the puzzle cuts do not intersect each other or self-intersect. We conservatively enforce a minimum piece size and prevent curves from intersecting each other by restricting each curve to lie within its own linear partitioning of the puzzle pieces. These dividing lines are shifted inwards by width over 2 to make sure neighboring curves obey a minimum width. For each curve, we apply a post-processing step to eliminate self-intersections and ensure a minimum width. First, we fix self-intersections in the original curve. Then we take the positive offset curve at distance width over 2 away and fix self-intersections in the positive offset. Then we offset back to undo the positive offset. Then we take the negative offset curve at distance width over 2 away and fix self-intersections in the negative offset. Finally, we offset back to undo the negative offset. Our output curve does not self-intersect and obeys a minimum width since neither of its offsets self-intersect. Finally, we use a laser cutter to fabricate our puzzles. Here are some puzzles we have created. Our method produces interlocking jigsaw puzzles whose pieces follow color lines, match the general shape of a user-drawn curve, and satisfy the necessary fabrication constraints. We create personalized jigsaw puzzles that are fun, challenging, and aesthetically pleasing.